Muy buenos días, bienvenidos de nuevo a Negocios Televisión, bienvenidos a este especial informativo, como siempre, atentos a las últimas horas y un día más poniendo el foco en el 3i Atlas. Durante los próximos minutos vamos a hablar con algunos de los principales científicos del mundo, después de que, como les contáramos hace apenas unos minutos, Elon Musk hablara también sobre este fenómeno, diciendo que podría incluso arrasar un continente después de que la semana pasada contáramos con Avi Loeb. Hoy vamos a volver a tener a este científico de Harvard después de que el 3i Atlas atravesara el sistema solar con algo más de brillo de lo habitual, también con un movimiento bastante raro. Enseguida vamos a contarles qué ha pasado en las últimas horas y sobre todo vamos a empezar esta cuenta atrás para el próximo 19 de diciembre, el momento en el que el 3i Atlas va a pasar por su punto más cercano a la Tierra. Enseguida vamos a ir con las entrevistas, pero antes vamos a poneros en situación. Imaginen que de repente un objeto del espacio profundo entra en nuestro vecindario cósmico. No es un asteroide común ni tampoco es un cometa típico, es 3i Atlas, un visitante interestelar que viene de otro sistema solar. Su llegada nos ofrece una oportunidad única de observar material que jamás se había formado cerca de nuestro Sol. 3i Atlas significa hacer interestelar object, es apenas el tercer objeto confirmado que viaja por el sistema solar desde otra estrella, detectado por el telescopio Atlas en Hawái, especializado en rastrear estos objetos cercanos a la Tierra. Se comporta como un cometa con coma y cola de polvo y gas, pero su trayectoria y velocidad lo delatan, y es que, según algunos expertos, no pertenece a nuestro sistema solar. Hablan de las decenas de kilómetros por segundo que alcanza, también de su trayectoria hiperbólica y del tamaño estimado entre 500 metros y 1 kilómetro de diámetro. 3i Atlas nos permite analizar material de otra estrella y descubrir pistas sobre cómo se forman los planetas en otros sistemas. Podría contener compuestos orgánicos o incluso agua congelada, piezas clave para entender la química de la vida. Observatorios de todo el mundo compiten por captarlo. Para la industria espacial impulsa inversión y tecnología en seguimiento de objetos cercanos a la Tierra. En redes sociales y en YouTube están generando un enorme engagement, misterio, ciencia y espectáculo en un solo evento. Uno de los hombres que desde luego más están dando que hablar a tenor de este estudio sobre el 3i Atlas es Avi Loeb. Él es físico, científico de Harvard, que de nuevo está con nosotros en Negocios Televisión. Hi, Avi, thanks for being again with us here in Negocios TV. It's a pleasure having you here. Thank you.
My great pleasure to join you.
Thanks for being here in Negocios TV, talking about the 3i Atlas. We would like to do more questions. I would like to ask you about this meteorite. What is different from this 3i Atlas?
Yeah, so 3i Atlas was discovered in July 2025, and it has 9 anomalies, things that are quite unusual about it. First, its size. It's bigger than 5 kilometers. And about 1 million times more massive than the first interstellar object that we discovered 8 years ago, Oumuamua. And so it's surprising that the third object we find is 1 million times more massive than the first one. And moreover, it lies in the plane of the planets around the sun. It came very close to Mars on October 2nd. And then it will come close to Venus shortly, and eventually get very close to Jupiter on March 16, 2026. And that begs the question of whether the trajectory was designed by some intelligence. There was also nickel with very little iron coming out of it. Also, not much water coming out of it, only 4% by mass, as far as we saw. And just a few days ago, it came closest to the sun on October 29th. We couldn't see it from Earth because it's on the opposite side of the sun, but some other observatories that are orbiting the sun were able to look at it, and it became extremely bright very rapidly close to the sun, and obtained a color that is bluer than the sun. And in addition, it displayed some non-gravitational acceleration. It deviated from the original trajectory that we expected it to go on. And that, if it's a natural comet, then we would expect that it lost about 20% of its mass. So there should be a very massive cloud of dust or gas around it, weighing of order 5 billion tons. So in the coming weeks, we should be able to tell if there is a very massive cloud of gas around it, in which case it might be a comet of natural origin. But if we don't see this massive cloud, then the non-gravitational acceleration that it displayed may have originated from something else, maybe an engine, maybe it's a technological object. So we should keep our options open as of now until we get better data.
Waiting for more data, Avi, I would like to ask you about the 3i Atlas, and we would like to ask you about if it could be the first step toward discovering life or intelligence beyond the Earth.
It could be if it happens to be technological in origin. There is a question of why it arrived in the plane of the planets around the sun. Why is it so massive? A million times more massive than the first object. We should have seen millions of those smaller objects before we see a big one. And also all kinds of other anomalies about the material that it has and the kind of glow that it had ahead of it, in front of it, towards the sun early on, opposite to what we often see in comets. So the verdict should come out of the data that we will get in the coming weeks. It will get closest to the Earth on December 19th, about 6 days before Christmas. And my hope is that it will not deliver any unwanted gifts for the holidays to Earth. We should watch it. We should check if there are any probes that may have been released by such an object, and they arrive to Earth or to Mars, where we have orbiters that can monitor the situation.
Waiting for this 19th of December, I would like to ask you about the 3i Atlas and the change speed and direction in its tail. Why does 3i Atlas has made these changes?
Yeah, so this change in trajectory was reported on October 29th, just a few days ago, and it was inferred from a deviation that was measured by the ALMA observatory in Chile, and we are still waiting for more data, but I calculated that if this was triggered by mass loss as the object got close to the sun, so that it got a recoil in the standard way that comets get, then it should have lost a significant fraction of its mass, about a sixth of its mass, and that implies that there should be 5 billion tons of material around it that were lost, and it's a major mass loss that should reveal the nature of the object if that's the case. But it could also be a completely different propulsion method that has to do with technology, and for that we have to keep our minds open. And so we will see in the coming weeks what the origin of this non-gravitational acceleration is, how big it is. But the first time it was reported was just a few days ago.
Maybe some people, some experts are talking about this 3i Atlas, this acceleration, and some people is talking about that it's becoming more brewer. What do you think about this?
Yeah, so the acceleration, I should say, if it came from a technological origin, then it makes sense, because you expect to get the most efficient boost to the velocity at closest approach to the sun, taking advantage of the gravitational assist of the sun. We do that with spacecraft. But in general, we just don't know what is the origin of that acceleration, and the object became indeed bluer than the sun when it came closest to it. That's surprising, because usually when an object loses mass in the form of dust, the dust reddens an object, it becomes redder. And also red means a cool temperature. And usually we expect these objects to have much cooler temperature than the surface of the sun, because they are at a distance from the surface, and we expect the 3i Atlas to have a temperature of order a few hundred degrees above absolute zero. That's 20 times smaller than the surface temperature of the sun of 5,800 degrees. So it should have appeared red relative to the sun. Nevertheless, it's blue. So there are two possibilities again. One is that this blue color was obtained from carbon monoxide that lost an electron. That's a molecule that can, in principle, generate blue light. And if there is a lot of carbon monoxide, the CO, near the object, it might be the origin of the blue light. But another possibility is that the object has an engine that is much hotter than the surface temperature of the sun, and that's where the blue color comes from.
Well, waiting for more info about these three atlas, I would like to ask you about this Hawking sphere, this Stephen Hawking sphere, who talk about remain silent in the face of possible alien civilizations. What do you think about this Hawking sphere of talking about these subjects?
Yeah, it's possible that the aliens are not far from us, and they're listening, and they respond to whatever happens on Earth. We were not careful. We were transmitting signals throughout the last century, and the question is someone listening? And it's possible that we would get a visit once we pose a threat to a neighbor that we are not aware of. And so it would have been wiser for us to be more careful in transmitting signals. But, the cat is already out of the bag. And as of now, we just need to monitor objects that enter the solar system to make sure that all of them are rocks. And none of them is a tennis ball that was thrown by a neighbor.
Well, a lot of questions about these three atlas. I would like to ask you about the NASA. Is it true that the NASA has hidden the best photo of this comet, of these three atlas, the best photograph?
The highest resolution images that were obtained of 3A Atlas were taken on October 2nd and 3rd by the HiRISE camera on board the Mars Reconnaissance Orbiter. We haven't seen those images, and that's quite unfortunate because they have a resolution of 30 kilometers per pixel. So we can, in principle, see the vicinity of the object and infer how big it is. It's also a side view of the object for the first time that could give us a lot of information about the material coming out of it. So this data is very precious, and it's time sensitive because when we analyze this data, we can infer what kind of future observations we want to take. But unfortunately, NASA did not release this data because of the government shutdown that started on October 1st. And I just think that scientific data should not be held hostage to politics, and it doesn't take much effort to actually share the data with other scientists. Representative Anna Paulina Luna sent a letter on Friday, just a few days ago, to the acting administrator of NASA asking that the data would be released. I contacted the principal investigator of the HiRISE camera, and I didn't get a response to my emails. So this is unfortunate because the acting administrator of NASA did respond to Kim Kardashian on the same day that Representative Luna sent her letter. Kardashian was curious about the 3A Atlas and asked for more details about it. And Sean Duffy, the administrator of NASA, responded immediately and explained that there is nothing to worry about, no risk to Earth, and he explained to her what 3A Atlas is. So apparently, he was much more willing to respond to Kim Kardashian than to a request from Congress and a scientist, the scientific community that really wants to analyze this data. And I hope the data will be released very soon.
Waiting for this data, waiting for the NASA. I would like to ask you about the 19th of December. We were talking about his pass for the land. When will this comet pass by, and does it pose any danger to the Earth?
There is no danger to Earth if it continues along the path that we are expecting it to go through, as long as it doesn't maneuver and start to approach us, or as long as it doesn't release any mini probes that approach the Earth. We should be completely safe. The closest it gets to Earth is about 250 million kilometers, according to the predicted trajectory. That's not very close. We shouldn't worry about any impact on Earth. In fact, it was avoiding Earth even when it came closest to the Sun. It was on the opposite side of the Sun relative to Earth. The key point about the 19th of December, when it gets closest to Earth, is that this would be the best time to observe it. And there are hundreds of observatories around Earth that could look at it. In fact, there is a campaign that is organized by the International Asteroid Warning Network that decided to coordinate these observations between the 27th of November and the 27th of January. And this is an organization that is embraced by the United Nations. I'm very happy that they initiated this campaign, because I sent also a white paper to the United Nations a few weeks earlier, encouraging them to do just that. The best way for us to learn about the nature of 3I Atlas is by collecting as much data as possible. If we assume that we know the answer in advance, the way that some scientists pretend, then unfortunately, we might not be eager to collect the data, and that's the worst we can do.
Working for this 19th of December, I would like to ask you about what could say this 3I Atlas if it could talk to us. What do you think it would tell us about its origin?
Yeah, so that is a very interesting question. Even if it's natural, it's clear that it's very different from the known comets in the solar system, because so far it shed mostly carbon dioxide, and very differently from comets that we are familiar with in the solar system that are water rich. And also it had a glow in the direction of the sun instead of going in the opposite direction, the way we see for comets, and has nickel with very little iron. So all kinds of anomalies that we are not familiar with. And we can, once we understand what these mean, once we know more about its nature, then we can infer where it may have come from. It came with a very unusual speed of 60 kilometers per second relative to the sun when it entered the solar system, and that's much higher than the typical local population of stars. So if it's natural, it should have come from an old star. The old stars are usually getting a lot of kicks to their velocities during their lifespan. And in addition, it should have formed under circumstances that are different than solar system comets. And if it lost a substantial fraction of its mass when it came close to the sun, we can analyze that and figure out its composition nature. Now, if it's technological, of course, it's a completely new experience for us. And this is a giant object, bigger than a city. So the question is, how did the civilization launch such a massive object? And what kind of power supply does it have inside? Our biggest rocket is a Starship, which is less than 100 meters, less than the size of a football field. This one is the size of a city. It's very different dimensions. So there are probably a lot of things for us to learn from whichever technological civilization sent it. And the best way to learn is by getting as much data as possible about it when we have the opportunity. The benefit of 3I Atlas is that it came in the plane of the planet, so we have a lot of observatories that can look at it. It's also very big, so it's quite bright, and we can detect it with many instruments. So altogether, it's a gift from interstellar space, and I see it as a blind date. And in a blind date of interstellar proportions, it's very important to observe the other side rather than to have an opinion prematurely.
Talking about some opinions, Avi, I would like to ask you about Elon Musk. He was talking today about these three-eyed atlas, and he said it would obliterate a continent. What do you think about these remarks from Elon Musk?
Oh, definitely. I mean, he was talking with Joe Rogan on the podcast a couple of days after I appeared on Joe Rogan. So you can check the details of what I talked with Joe Rogan as well. But what Elon Musk says is correct. I mean, the mass of this object is bigger than 33 billion tons. So it's comparable to the mass of the asteroid that killed the dinosaurs 66 million years ago. It's a very massive object that would create a lot of damage if it collided with Earth. But as of now, it doesn't seem to approach Earth. It would be relatively far, so we don't need to worry about it. The only thing, if it's technological, it might actually release some mini probes that we can look for, or we should watch out its non-gravitational acceleration, whether it changes direction and starts approaching the Earth. Then, of course, everything will change.
Well, a lot of questions about these three-eyed atlas. I would like to ask you about yourself. Avi, you have been criticized for challenging the scientific consensus. Why do you think the academic establishment reacts like that to the ideas that are not the ordinary, are a little different? What is your answer for these people?
Well, science is a great privilege because it allows us to stay curious and not assume that past knowledge describes everything we see. So science should be guided by data, by observations, rather than by prejudice. We know that from the days when the Vatican basically put Galileo Galilei in house arrest because he said something different than they were arguing for. And the Earth was moving around the sun for 4.5 billion years before the Vatican even existed. So whether my colleagues are saying something or I say something is completely irrelevant as to what nature brings to our backyard. We just need to observe it, collect as much data. And in case we see anomalies, we should be curious about them rather than push them aside. And the reason is simple. A technological visitor to our backyard, something that was sent by another intelligence, poses immediate consequences to the future of humanity. And we need to consider it seriously because even if the probability for that is small, the implications are huge. And when you multiply small probability by huge implications, it means that you need to take it seriously. This is called the black swan event, and the intelligence agencies take seriously events that could have a low probability but have huge implications. Scientists are not used to that because they often deal with very little consequences to society. If we were to consider an exploding star at a distance of billions of light years, nothing will change in our daily life. But when we have a visitor to our backyard, it might enter through the front door. And so we should take seriously the possibility that it might be technological and use as much data as possible to figure things out. And those critics that say we should not discuss this possibility because it's unlikely, they don't understand how we need to face societal threats. And it's a very different situation than we usually encounter in science.
The science talking about these three-eyed atlas. Avi, thanks for being with us in Nautheos TV. Thanks for answering all our questions. It's a pleasure having you here. Thank you so much, Avi. Thank you.
It was a great pleasure joining you, and I will be glad to speak with you anytime in the future. Thank you.
Thank you so much, Avi. We are talking about these three-eyed atlas. Vamos a seguir con más entrevistas, con más expertos sobre este tres-eyed atlas. Escuchaban a Avi Loeb comparando este asteroide con el que acabó con los dinosaurios. Nos venía a decir también, bueno, pues que no tenía mucho sentido que el tres-eyed atlas pase cerca del Sol y se vuelva azul en lugar de volverse rojo. Nos hablaba también sobre estas declaraciones de Elon Musk, que les contábamos a eso de las 12 de la mañana aquí en España, que decía, bueno, pues que podría podría arrasar un continente. Nos confirmaba el propio Avi que está en lo cierto. Nos decía, bueno, pues que su tamaño es comparable al asteroide que acabó con los dinosaurios. Vamos a analizar más cuestiones, vamos a seguir analizando este 3 y Atlas de la mano de Eric Keto, astrofísico del Observatorio Astrofísico Smithsonian. Hi Eric, thanks for being here in Authors TV. It's a pleasure having you here.
Hello, thanks for having me. I was delighted to see my friend and colleague Avi Loeb on the show just before me.
I would like to ask you about this, Eric. What do you think about Avi Loeb and all his investigation about these 3 Atlas?
Well, Avi Loeb and I work together, and of course, we agree on everything except when we don't. But in general, I think it's worthwhile asking these questions. And we can also ask questions, and everybody is, if there is a natural physical explanation for these anomalies that Avi Loeb pointed out, and we haven't come to the complete answer on those.
What is your opinion about these 3 Atlas? Why is different, for example, from the 2i Borisov?
In physical terms, the 3i Atlas is unusually rich in volatiles like water, ice, frozen water, and carbon dioxide and carbon monoxide. A normal comet would have about 50% of its mass in carbon and silica grains, and this comet shows less evidence for emissions from carbon and grains. So it's possible that it certainly came from another planetary system, and it may have been ejected at an early stage before the surface of the comet was processed by many orbits around its star. So it may represent a good example of pristine material from another planetary system, and we don't have this sort of comet in our solar system that is as close as this one. There are comets that are orbiting far away from the sun that may have similar characteristics, but this one was good enough to come by so we can study it in more detail. So it's, in general, it's of great interest to the astronomy community.
There is a lot of interest, there is a lot of hypotheses. What do you think about the people who talk about an stellar ejection, a binary system, or an interstellar debris? What do you think about all the hypotheses about these 3 Atlas?
I'm sorry, which hypotheses?
All people who says that it is an stellar ejection, an interstellar debris. What is your hypothesis about these 3 Atlas?
Yeah, well, they're of course highly speculative, but they're questions that are worth considering. My guess is it will probably turn out to be a comet, natural comet, but we have to wait and find out.
Wait, we have to learn about these 3 Atlas. What lessons could we learn about these 3 Atlas and for the scientific community in general?
Well, as I said, first of all, it represents a comet from another planetary system, and we have no information really about comets and other planetary systems, except for the ones that happen to come through our solar system. And so far, there's 3, or one possible asteroid and 1 comet, 2 possible comets. So this is a great opportunity to learn about other planetary systems. And as I said, it could be a comet that comes from a different stage in the formation of the planetary system, than is more easily observed in our solar system.
And Eric, what are the technical challenges that you face when observing an object that is, for example, so fast that like these three atlas? What are the challenges you have to investigate about these phenomenon?
Well, comets are somewhat like people. They're all individuals. However, they have common characteristics. But they're more varied than some other astronomical objects. So every time we collect data on a collection of comets, we have averages and we have outliers. And so we have to take that into account, that there are unusual comets that have different kinds of anomalies that aren't completely explained, and 3I Atlas may have, it's a little bit more gas rich than typical solar system comets and so on. So we have to fit those into our physical theories, those facts. So the observations are, we have the observatories and the assets that we have. So we have to make the best use of those, but they're not limitations, really.
And Eric, what can 3I Atlas teach us about the formation of planets and materials in other star systems?
Well, it's we can and we are collecting an inventory of the chemical composition of the comet, and that's certainly one thing. And it would be, so far it's nice to know that the formation processes in other planetary systems may be similar to those that we infer from our own solar system. So that's certainly of interest. Or if we were to find that they were different, that would also be of great interest.
And Eric, do you think that in the future we will be able to send an interception probe to an object like this 3I Atlas? We could study better this, for example, this 3I Atlas or the 2I Borisov?
Yeah, it's possible. It depends upon the amount of advance warning that we have. For example, NASA did send a probe, the DART mission, to collide with a nearby asteroid. That asteroid was considerably closer to Earth than 3I Atlas is, but nonetheless it took 1 year for the probe to orbit around the Sun and align itself for the rendezvous. So there are large distances in space, and the probes travel at limited speed. So it's certainly possible, but it would take some advanced planning.
And Eric, what degree of consensus do you have in the astronomical community? What is the consensus in this moment about the 3I Atlas?
Well, the consensus really is that 3I Atlas is a natural comet. Now, and Avi Loeb has just a minute ago commented on that, whether people are willing to ask questions, unusual questions, speculative questions about its origin, but that's certainly the consensus.
And do you expect some 4I in the future? Do you think 3I Atlas could be the last like this? Do you expect an 4I in the future?
No, the Planetary Defense Network was initiated by an act of Congress in 2005 and gave NASA a directive to identify 90% of the asteroids and comets in near-Earth orbit. now greater than 140 meters. Now, this has allowed the construction of 4 new observatories, one which came online in 2016. The most recent came online just before the discovery of the comet. That was the Vera Rubin Observatory. And there's another that's called FlyEye, which is built by the European Space Agency, located in Italy. That hasn't come online yet. But these capabilities are going to vastly expand our detection and inventory of all kinds of comets, including those from interstellar space. So we should expect many more of these events in the near future.
And Eric, how could help these three atlas? How could help the scientific community? Do you expect more money, for example, for the future?
Do I expect more what?
More interest for the people, for your work.
Oh, I think so. I think as astronomy is really an observationally driven science, and as more discoveries, observational discoveries are made, there's more interest in studying these objects theoretically, and so I think that will this is already generating a lot of interest, and when future observations discover more interstellar objects, this interest will definitely increase.
There is a lot of people talking about his pass for the Earth. Elon Musk was talking in the last days about these three atlas. He said it could obliterate the whole continent. What do you think about Elon Musk? I don't know. A lot of people talking about these three atlas. Is it good or is it bad for the scientific community?
Well, if it were to obliterate a continent, that would certainly be bad for the scientific community. The three-eye atlas is, as Avi said, is quite large compared to most of the asteroids and comets that are in Earth-crossing orbits from our own solar system. So it's a very unlikely event that that there would be a collision, but yeah, I don't know. Elon Musk's statement seems rather general and certainly true, but I'm not sure the significance of it.
Bueno, pues a la espera de conocer más información sobre este 3i Atlas, Eric, thanks for being here with us in Negocios TV. It's a pleasure having you here. Thank you so much.
Okay, thank you.
Bueno, seguimos dando vueltas a este 3i Atlas, estas declaraciones de Elon Musk y también a la entrevista que teníamos hace apenas unos minutos con Avi Loeb, el científico de Harvard que hablaba de este 19 de diciembre, la fecha en la que se espera que pase por su punto más cercano al Sol. Nos decía Avi que espera que no tengamos un regalo antes de Navidad. Vamos a escuchar este momento, este mensaje que nos dejaba el propio Avi Loeb. Decía que el veredicto lo sabremos en unas semanas. Decía, se acercará el 19 de diciembre a la Tierra y esperemos que no nos deje un regalo antes de finales de año. Este es el mensaje que nos decía hace apenas unos minutos Avi Loeb.
The verdict should come out of the data that we will get in the coming weeks. It will get closest to the Earth on December 19th, about 6 days before Christmas, and my hope is that it will not deliver any unwanted gifts for the holidays to Earth. We should watch it. We should check if there are any probes that may have been released by such an object, and they arrive to Earth or to Mars, where we have orbiters that can monitor the situation.
Esperando al próximo 19 de diciembre, nos hablaba Avi Loeb sobre esta fecha que está marcada en el calendario. Va a ser el punto, va a ser el momento en el que pase por su punto más cercano a la Tierra. Eso sí, estamos hablando de miles de millones de kilómetros. Vamos a analizar estas cuestiones y mucho más de la mano de Tessa Frincke, astrofísica de la Universidad de Michigan. Hi, Tessa, thanks for being here in Authors TV. It's a pleasure having you here. Thank you.
Hello.
We are talking about the three atlas. We would like to ask you about the three atlas and what is different, for example, from the UI Borisov.
Yes, so the 3i Atlas is different from our first two interstellar objects. It's much faster, and it's having a lot of material being blown off of it, much more than it's the second interstellar comet 2i Borisov. And it's much different than our solar system comets because it comes from a solar system outside of our own. So we get to learn more about early planet formation from those systems.
Tessa, what can we learn about these three atlas? What is showing us?
You're right. So as the 3i Atlas got closer to the sun and is going to come back around, it's outgassing a lot of materials, and those materials are from the early formation of planets in a extrasolar system. So we get to see the most pristine materials and the earliest materials that these planets were being formed from, and those are outgassed from the comet, and we'll get to see that as it comes around from the sun and gets closer to the sun and comes out, and we'll be able to see it from ground-based observations.
Tessa, we have been talking with Avi Loeb, this Harvard scientific who has a lot of hypotheses about these three atlas. What do you think about Avi Loeb and everything he says about the three atlas?
Well, I know for sure that most astronomers in the community believe that 3i Atlas is a comet, and it exhibits typical comet behavior, such as outgassing that we've seen, brightening as we get closer to the sun, typical tail switching. So I believe that it's just your plain old comet, just like the ones that we see in our solar system, but more unique in the fact that it comes from a solar system outside of our own.
When we talk about his size, his speed is different, for example, from the Oumuamua, the Borisov. Why so big, these three atlas?
You said why is it so? Can you repeat the question?
Why so huge, so big, these three atlas? His size is different, no, from the others.
I'm not sure how much different the size is, but we're definitely seeing a lot more vigorous activity from 3i Atlas. This could be in part due to the size. I'm not sure how big the nucleus of the comet actually is, because a lot of that is obscured by what we call the coma, which is like the sort of shell that it gets covered by all of the outgassing materials like water and CO2 and all of that. It kind of obscures the nucleus, so it's like kind of hard to say the size, but I guess it is a little bit bigger than our Oumuamua and Borisov.
Talking about these three atlas, we are waiting for the 19th of December. Do you think this three atlas is a threat to the Earth?
I think that oh, you mean like when it's observable from Earth? Yes. Yeah. So right now, it just made its closest approach a couple of days ago on October 29th, but we're kind of in a spot where the 3i Atlas is just behind the sun and we can't really observe it from the ground, so we're kind of relying on our space-based missions to view it. But once it comes around the sun, and we'll be able to see it from ground-based observations as early as late November and then into December. But it's an exciting time to view it because it has been processed by the sun and is outgassing a lot, and then it will be at the brightest point. This point, we will be able to see deeper into the nucleus. As I said before, the coma sort of obscures the nucleus. So at that point, a lot of that outgassing has occurred when it made its closest approach to the sun. So we'll be able to see deeper into the nucleus and see all of those pristine materials that I was mentioning earlier. So it will be a very exciting time to see all of that.
And Tessa, what can we learn about these three Ayatolahs? How can we learn for the future?
For the future, of course, yeah. So with every interstellar object that comes through our system, we learn more and more about how we can study this rare object, and we can make plans for doing possibly a space-based mission where we can intercept an interstellar comet sooner. There's been multiple studies about how we could do this, or how we could utilize other space-based missions that are already in service. So that's another possibility for like direct imaging of an interstellar comet, maybe for future reference. And then there's also the Vera Rubin telescope that's coming online and is projected to at least observe one interstellar comet per year or more. So that is a very exciting prospect, in that we're going to be able to see more and more of these interstellar objects instead of just like one every decade or so. So that will be a very exciting time. And then what else can we learn? Well, we can learn about like I said, what the chemical composition is of these extrasolar planetary systems, and we can learn about and it can give us some context for the evolution of our own solar system.
And Tessa, how could it help the scientific community? A lot of people is talking about these three Ayatolahs. You have a lot of focus. How could help in the future? Do you think we could see, for example, more money for your work?
I think that it's a very exciting topic for just the community at large, and then for astronomers in general. I think that if a lot of people stay excited about this really cool object, and the prospect that we'll see even more of them going forward because of our advancements in technology, I think that we could see more funding for this. As of now, like in the United States, we have the government shutdown, and a lot of science funding depends on what the government's doing. So the immediate future is a bit uncertain, but I am hopeful that the community's excitement about this object will lead to more funding and more research on this cool object.
What can these three Ayatolahs teach us about the formation of planets and materials in other star systems?
Right. So comets, they're like debris, like little pieces left over from planet formation. So they're formed pretty far away from their host star. So they kind of freeze out all of those materials inside of its nucleus. So it holds on to those very earliest chemical compositions that formed planets. So they hold on to those materials, and as they move through the galaxy and they approach stars like our own sun, they warm up and they outgas, and all of that material is blown off, and we can observe that and learn specific things about the composition that was and those earliest conditions in those extrasolar systems. And we can also learn a little bit about where the comet was formed in their source system, about how far away was the comet when it formed from its host star, and based on what kind of temperatures those materials condense at.
Waiting for more info about these three Jadlas, I would like to ask you about what is next in the study of the three Jadlas. We are waiting for the 19th of December. What could be or what would happen later? What would happen far from this 19th of December?
Right. So we know immediately, like, we'll be able to see a lot of the brightening that we expect from a comet that has just had its closest approach to the sun. And then we will, I guess, like, outwards of that, we'll be able to, like, continuously monitor the three atlases activity, whether it experiences brightening or if it experiences a non-gravitational acceleration, or if we're just going to continue seeing outgassing influence its orbit. And then we'll just be able to collect the time evolution of 3I Atlas before it leaves our system, which is also exciting in itself.
Waiting for this 19th of December. Tessa, thanks for being here in Authors TV. It's a pleasure having you here. Thank you. Thank you so much for being here.
Thank you.
Thank you. Good day. Nosotros
Have a great day.
terminamos ya este especial sobre el 3 y Atlas con el próximo 19 de diciembre marcado en rojo nuestro calendario, el momento en el que pase por el punto más cercano al Sol, contrastando las opiniones en torno a estas teorías de Avi Loeb, que bueno, nos está alertando sobre este 3 y Atlas, pone sobre la mesa que podría ser tecnología extraterrestre y sobre todo, bueno, pues lo escuchaban hace apenas unos minutos, culpando a la NASA de ocultar la mejor fotografía que hay sobre este 3 y Atlas y dejándonos un titular. Dice, bueno, que ya no es solo que pueda arrasar un continente, sino que este 3 y Atlas es lo más parecido al asteroide que terminó con los dinosaurios. Muy pendientes del 3 y Atlas de las últimas horas en este sentido. Vamos a hacer una pausa y enseguida más información en Negocios Televisión.